When we first created Stupid Physics Tricks for this project, I had no idea we were hitting this cultural touchstone that would become so much a part of the national conversation in science education. I had no idea that they would be seen by hundreds of thousands of people every day. Hundreds of people every day.
All the time.
Oh, hundreds of people in total. So I hope you'll gather your family around the screen and watch this very special Stupid Physics Trick. Welcome to Stupid Physics Tricks for the week. Remember, this is only a demonstration. It's not on the examination. So please, no studying. This week we have Wesley Adams. Come on down. And Wesley, where are you from?
I am a science teacher from Klein High School up in North Houston.
All right, very nice. And what are you going to do?
Well, I'm going to show you how to remove a pesky oil stain from a sheet of paper.
All right.
It's actually very, very easy. No special chemicals required for this.
All right.
Physics tricks, after all.
Yeah,
all you have to do is you take the paper and you'll hold it up.
Yeah.
And then you just slightly turn it.
Yeah.
And eventually it should disappear.
It does look different. So that's an oil stain in the center of a piece of paper. Huh. So as you turn it, it looks very different.
Yes. So there's actually a cool little physics thing going on here. Some stuff you might have not known about paper.
Yeah.
Is that paper is actually transparent. So it looks normally very white, but it's made up of these cellulose fibers, and these fibers are all interconnecting and intertwining together, and they're basically immersed in air. And what you know a little bit about light will undergo refraction when it goes through different mediums. So it'll pass through the cellulose and everything's fine, but when it hits the air, it tries to bend a little bit.
Right, so you're seeing lots of reflections off all those little fiber surfaces, right, why paper is white. But where the oil is, so what's going on where you have the oil?
So the oil, you can find out, oil has the same refractive index as the paper does. It's very similar. So it's not perfectly transparent, but it is similar enough that you get this very clear light effect.
Okay,
and
so how did you make it
the,
disappear then? Right?
So what you do because it's transparent and the rest of the paper is reflective, if you tilt it, you can actually see which side of the paper is brighter. So if you tilt it this way and the oil spot is darker than the rest of the paper, that means that there's less light on the back of the paper and more light on the front. If you tilt it the other way and you see that the oil starts to brighten, that means that there's more light on one half of the paper and less light on the front. And so you just find that nice middle ground.
You can make it disappear
and
at
it just
one
disappears.
angle. Yeah,
that's right.
Very cool physics trick. Well, very nice. So I like that.
So I have this other trick here. I'm going to show you. Yeah. So this is a nice little party trick. If you have these little beads right here, these are ceiling fan beads, lots of party beads. You need a long chain of it though. And so I'm just going to challenge you. Here is to, what I'm going to have you do is I'm going to drop these beads. And I want you to stop them from falling entirely out of the glass. So if some of the beads stay in the glass, that's totally fine. I just want at least some of the beads left in the glass. Okay, so I'm going to drop it up, and here we go.
I'll just try to grab them.
Well, okay, well you can, I mean if you...
Yeah, I didn't quite...
That's all right, that's all right. If you can put those back in there.
Sure, yeah.
So what these are actually, we can call these self-siphoning beads. And it's just a chain of beads on the same string or same strand. And so what happens is when one bead accelerates down because of gravity, it causes a tension force. It pulls along that string, and all the other beads in the cup get pulled along that string. Since it's going up, though, those beads are having to accelerate upwards. And as they accelerate up, you might have noticed this, that you started to get this arch that formed over the glass.
It looks like the path a bead would take in, 2D motion or something like that. Yeah.
And so you can see this pattern. And so actually you can experiment with this if you allow the beads to accelerate further, so give them more time to be accelerated by gravity. The beads in the glass will have to accelerate more quickly in the upward direction, and so it takes more time for them to change direction into a downward vector.
I see. Wesley, you got a lot of beads here.
I do have a lot of beads.
You've got an impressive quantity of beads.
And
okay, let's get them. Okay,
I want to show you actually a trick for doing this. So if you use here,
so is there a way to stop them?
There is. I'm going to unhook this right here, so we can.
There we go. We'll shorten it a little bit.
Excellent. All right. You got that?
There you go.
Perfect. So there is a trick to stop them. So because the height of the bead determines how fast it's accelerating because of gravity, basic kinematics equations, you just have to change the height and it'll stop.
Oh, that's how you, okay. So I could have, if I'd really been thinking about my physics, stopped them.
Yeah.
This has been a great double feature.
Okay, so I have this other
trick,
one here. Oh, well, may I have this? just wanted to
All
share
right, all right.
this here.
He came all the way from North Houston. so,
Exactly,
yeah,
it's
yeah,
very far.
Yeah.
But this is actually going to be something a little dangerous. This is probably, in fact, my stupidest physics trick.
All right.
If you decide to do this physics trick,
you go.
don't do it.
Okay.
You will burn yourself. And so I have a special formula here that's homemade. Never be able to guess what it is.
Let me see that.
When you see.
I have some idea what that is.
I don't know. So,
yeah.
this is a ball of woven cotton, not a cotton ball. It's very important that it's one,
Ball
not
of
the other.
woven
Ball
cotton.
Woven cotton. Mhm.
Yeah,
Yeah, you might be missing a T-shirt. In
yeah,
the
I
back,
think
actually.
I am missing a T-shirt. So.
And what I'm going to do here is I'll ask students. I'll say, what is the best, or really, I'll ask them. How do you tell if cotton is conductive or not? Is it a good conductive material or a poor conductive material?
Electrically or thermally?
Thermally, that's what we're looking
okay.
for.
Yeah.
And so a lot of students will say, oh, it's a poor conductor because you can use it to take hot things out of the oven.
Right.
Some of them will say it's a good conductor because it catches on fire easily.
Yeah.
So we're going to combine those two together and see what happens.
Okay, so your
you have
magic
the cotton
formula is fuel, basically, yeah.
Yep. And we're gonna
Oh,
put this
wait,
here.
oh, all
And we
right.
can see it starts lighting up, and it's
you're gonna
actually
burn
cool enough
yourself.
that you can hold it in your hand as long as you move around. So
okay.
would you like to hold that for a little bit?
Sure, why not?
It does warm up some.
Oh, yeah, it's a little warm.
Yeah, you want to see that? And I can take that back here.
Yes, you can have
There
that,
we go.
yes.
And so we'll put that out.
Very
And
nice.
so we get to see through that the cotton, in fact, is actually a very poor conductor. It is, in fact,
Yeah.
an insulator thermally. And similar to the paper, it has all these woven fibers together, and there's a lot of
Right.
air in it, and that helps contribute to its thermal insulation.
Mm-hmm.
And this actually is a really good way to get students to realize the difference, but that heat and temperature are two different things.
Right,
You can have a
yeah.
lot of heat generated by that combustion reaction, but the temperature of the cotton hasn't actually increased very much. It doesn't transfer into your hand too
And the
much.
temperature of your hand doesn't get too hot. I think 50 degrees C is the threshold of pain or so.
Yeah.
So it was staying below 50 degrees C. Wow, a trilogy of stupid physics
Yeah,
tricks.
it's great.
I'm so glad.
Oh, by the way, I have one more
Oh
here.
my God, all right.
I just
What
this is something I think is just a good physics trick. This is I want you to pretend like it's your birthday.
All
Okay,
right.
It's
I
your
don't actually have
You
birthdays
get your
anymore,
birthday
but yeah.
candle. If you want to light that,
All right,
okay. So if you want to light that there,
all right,
you can use this to very stealthily steal someone's birthday wishes.
yeah.
This is a
So-
vortex cannon, made it myself, own design, right here.
Okay.
And
so
what I'm going to do is you can just say that you're the birthday boy. You have everyone singing the cameras. You have a
my
wish
party,
in mind.
Right, I'm about to blow it out.
I
got
have
my
a wish
birthday
too, though. I'm just going to think about that real quick, and
Yeah.
then when no one notices, I can
Yeah.
just.
Well, there goes my wish, and my wish was that this was over. So let's talk a little bit then. What is this thing called?
This is a vortex cannon, also known as a trash container with a hole cut on one side and a tarp taped onto the other.
Oh, okay.
It's really easy to make.
So you just tape this airtight, right, and cut a hole, and then you can blast little shots of air.
And you can actually add a couple things to it. If you're able to hook it up to like a fog machine or something else, you're going to get these cool smoke rings. So the vortexes that these guys form are actually these concentric rings. They're really cool to look at when you put that together. So
Very nice. Well, Wesley, I think the memory stick is full. So thanks very much for the greatest set of super physics tricks I think we've had.
thank you very much. It's great being here.